Hello, very good morning to all. We say good afternoon to all, right? So, today this is the fourth class of this chapter, and basically, if I'm talking about this is the second class, basically, if you're talking about the main chapter content. Before, in previous last two class, we are discussing only about the introduction and some important concept, right? So, this is the second part of the solution and the colligative property. In the previous chapter, we are discussing about the various concentration defining terms, right? And the Raoult's law, right? So we're talking about the Raoult's law. What is Raoult's law? What basically is how to find the mole fraction in the vapor state as well as the liquid state, right? So we already talked about the Raoult's law. I hope my voice is audible to all of you, right? And my screen is also visible. Please confirm me once so that we can begin with the today class, right? सबको सब स्क्रीन दिख रहा है, आवाज सबको आ रही है क्या? चलो, गुड. So let's start with the today's session. Okay, so basically, if I'm talking about the Raoult's law and how will you represent Raoult's law through a graphical representation, right? So this is basically liquid into liquid solution in which one liquid acts as what? One liquid acts as solute and the other liquid acts as solvent, right? So this is the phenomena in which binary solution taken into the consideration, right? Binary solution means we have a two liquids. Yes, someone. Yes. Okay. Right. So we have a two liquids. One is taken as a solvent and another is taken as a solute. Right. So let's study each of them. So we already studied this thing. The partial pressure of liquid A or component A is nothing but the product of the mole fraction into partial pressure at the pure state. Similarly, the partial pressure of the B is nothing but mole fraction of that component and the pressure at the pure state. Now, according to the Dalton's law, what is the total pressure, beta? Total pressure is the sum of the individual pressure, that is PA plus PB. So just put the value. So we get PT is equal to PA plus PB. We put the value of PA and PB, right? Good afternoon, sir. A very good afternoon to all, right? So we know this thing. If we get this PT, what? PT is equal to what we get? That is XA into P naught A plus XB P naught B, where P naught A and P naught B are the pressure partial pressure at the pure state. Remember this. This is the vapor pressure at the pure state. Now, we all know that XA plus XB is equal to what? Beta, the mole fraction of the binary solution. The sum of the mole fraction of the binary solution is always equal to 1. Yeah, that we already know in our previous classes. For the binary solution, the sum of the mole fraction is always equal to 1. So can we put the value of XA here? How will you put the value of XA, beta? Either XA or XB, you can put any of them, right? So let me put the value of XB. So we know that what is XB? XB is nothing but 1 minus XA. So we can put XB is equal to 1 minus XA and this is P naught B. So just multiply this. So what you will get? You will get XA, this is P naught A, and this is what? This is P naught B minus P naught B multiply XA. So just take XA one side, right? So you'll get P naught A minus P naught B, right? And this is nothing but XA plus PB naught, right? Plus PB naught. So this is what you'll get as the total pressure, right? So this is the total pressure. In this case, P naught A is more value, having more value than P naught B, right? So this is the expression for the total pressure for the Raoult's law, right? So if the solution follow this relationship, listen very carefully, if the solution follow this relationship, means if the total pressure is equal to this particular, that is P naught A minus P naught B XA plus P naught B, then we said the solution is to be ideal. तब हम solution को क्या बोलेंगे बेटा? Ideal बोलने वाले हैं कि solution क्या होगा? Ideal होगा. कब ideal होगा? जब वो इस equation को follow करेगा, right? Now, एक और question, what happen if the solution does not follow this equation? If the solution does not follow this equation, then it becomes non-ideal solution. Not follow means what? Not follow means either their value of PT is greater than this or lower than this. So according to the value of a PT, we classify non-ideal solution into further two types. That is the ideal and non-ideal solution. Right? That is ideal and non-ideal solution. So this is very much clear, everyone. Sabko clear hai yahan tak? If the solution follow this particular relationship, that is PT is equal to P naught A minus P naught B XA plus P naught B, then the solution is said to be ideal solution. If the solution does not follow this equation, then solution is non-ideal. And in non-ideal, we have a two case. Either this PT is greater than this or this PT is less than this. So according to this, we classify non-ideal as positive and negative deviation. I hope this is clear. सबको clear है यहाँ तक? जल्दी से बताओ. किसी को कोई भी doubt हो? Anyone having any kind of doubt, you can ask. और भी प्रोसीड आगे बढ़े. क्लियर है सबको? चलो, right. So let's see one important note here, beta. What the important note here? If the partial vapor, or we say if the vapor pressure of the P naught A is greater than the vapor pressure of P naught B, right? What is vapor pressure actually? How will you measure this thing? Vapor pressure means if the force of attraction between the solute or we say solute solvent is less, then they easily convert from liquid state to the vapor state. That is what vapor pressure now, right? So if the force of attraction is less, then we can say that more vapor will be produced, right? And their boiling point will be high or less. Obviously, their boiling point will be less because boiling point depends upon the force of attraction, right? If they are having more force of attraction, they are bounded so strongly, then definitely they are having a high boiling point, right? So this is very important note here, beta. If P naught A means if the vapor pressure of A is more than the vapor pressure of B, what this implies? This implies that A is more volatile than B, right? A is more volatile than B. What do you mean by the volatile? Volatile means they have a more capacity to produce vapor. They are more vaporized. They are easily vaporized, right? Yes. Anyone having any kind of doubt, Mahesh? You want to ask something? Or you just mute yourself, right? Okay. Chalo. So if P naught A is greater than P naught B, A is more volatile than B. Or we say the boiling point of A is less than the boiling point of B, right? The boiling point of A is less than boiling point of B, right? So this is how we actually conclude from this statement. That is, if the vapor pressure of the pure state of A is greater than B, then obviously A having lesser boiling point as compared to, right? So this is very much clear, I hope. Okay. Now, what are the limitation of the Raoult's law? So basically, Raoult's law only work for the ideal solution. This is for most important thing. That is, this law is valid only for the ideal solution. Or we say very dilute solution obey Raoult's law to a reasonable approximation, right? So these two are the limitation of the Raoult's law. The first one is Raoult's law only work for the ideal solution, and the next one is very dilute solution obey Raoult's law to a reasonable approximation only, right? So these are the two limitations. Now, अभी बात करी थी what is ideal and what is non-ideal. So let's see this thing. These are very, very important. Many times questions were coming from this topic directly. What are the characteristics of ideal solution? What are the reason for the ideal solution? When ideal solution is observed? What is the condition for observing the ideal solution? So these type of questions are generally coming, right? So what is ideal solution basically? Okay. So the first and the most important point is those solution which obey Raoult's law, right? So those solution which obey Raoult's law, right? So those solution which obey Raoult's law over the entire range of concentration are called ideal solution. So this thing is very important. Yani those solution which obeys Raoult's law over the entire range of concentration are called ideal solution, right? So this is the first point. Now, when the force of attraction between the AA, what is AA? AA means nothing but that is solute, right, beta? So this means solute. A means solute, right? So this is solute. B means solvent, right? B means solvent. It means they are a binary solution. So one liquid acts as a solute and another liquid acts as a solvent. So when the force of attraction between the solute and solvent is similar to the solute and solvent, then A and B will be form ideal solution. समझ आया सबको क्या बोल रहा है ये कि अगर फोर्स ऑफ अट्रैक्शन जितना सॉल्यूट का है, जितना सॉल्वेंट का है, अगर उतना ही फोर्स ऑफ अट्रैक्शन सॉल्यूट और सॉल्वेंट का भी हो गया, then they show ideal solution, right? So this is the first condition, that is it is must required for the solution to be ideal, right? So this is the second point. Now you know what is the ideal solution? Anyone? Any kind of doubt you can ask me till you know the definition of ideal solution. What is the ideal solution? In terms of force of attraction, can you define ideal solution? Yes. If the force of attraction between the solid solvent and solvent is similar to that solute and solvent, then it is said to be ideal solution. Right. Now, let's see from this diagram as well. This circle, this white circle, right? This one. So this represent the solute, right? So in ideal solution, the force of in the ideal solution, the force between the solvent molecules and this represent they are exactly the same as those between the solvent and solute molecules, right? So we have two circles. One is dark with darken and another is a white color, right? So these two represent the solute and solvent. दोनों क्या represent कर रहे हैं? Solute and solvent को. ये डार्क कलर से रिप्रेजेंट है वो सॉल्वेंट को कर रहा है और ये जो व्हाइट है वो रिप्रेजेंट कर रहा है सॉल्यूट को. सो ये क्या बता रहा है यहाँ पे ध्यान से देखो कि अगर फोर्स ऑफ अट्रैक्शन बिटवीन दीज टू, यू कैन ऑब्जर्व हियर these two only. If the force of attraction between these two is exactly equal to these two, right, solute and solvent, then we said to be they are the ideal solution. Okay, so this is the condition for the ideal solution. Now let's see the some properties of ideal solution, right? What are the various properties of the ideal solution? The first properties of the ideal solution is it must obey Rawls law. Yani Rawls law is obeyed. Otherwise, it won't said to be ideal solution. So for ideal solution, Rawls law is must, right? Second, delta H of mixing is 0. What do you mean by this thing? Delta H of mixing is equal to 0. Can anyone tell me? That delta H means enthalpy of mixing is 0. For example, if you mix two liquid, right? You have a two liquid, maybe one have a ethanol and one have a water, and you mix two liquid, then there is no heat evolve or no heat is required. Then this is said to be ideal solution. Means on mixing the two liquids, there is no heat evolve or heat absorb. Then it is said to be ideal solution, right? It means delta H of mixing is equal to 0. There should be not be enthalpy change when the components of ideal solution are mixed, right? So this point is clear. The first point is clear. Second point is clear, right? Now let's move to the third point. Delta V of mix is equal to 0. What is this delta V mix? Delta V mix means volume of mixing is equal to 0. What do you mean? It means if you mix 1 liter of alcohol, or we say 1 liter of ethanol with the 1 liter of water, then the resultant solution become 2 liter, right? So 1 liter ethanol, 1 liter water, resultant solution become 2 liter. It means there should not be change in the volume on mixing, right? So if there is not change in the volume on mixing, then they are also said to be ideal solution. So these three are the basic characteristics for the ideal solution, right? The first one, it must obey Rawls law. The second one, delta V of mixing is equal to 0 and delta H of mixing is also equal to 0. Example of such type of solutions are N-hexane, N-heptane, ethyl bromide and ethyl iodide, benzene and toluene, chlorobenzene and bromobenzene. They all are the example of ideal solution, and this one is very, very important, right? In many questions, right? In many PYQ questions, they generally ask, does annexin and heptane show which type of solution? Ideal solution, non-ideal, positive, negative. So you must know the example of each, right? So this form ideal solution. So N-hexane and N-heptane are the example of ideal solution. I hope this is clear to all of you. Anyone having any kind of doubt? किसी को कोई डाउट है, फिर कुछ पूछना चाहता है? Yes? No? All clear? Chalo. Now, the fourth important point is delta S of mixing is equal to positive. Delta S mixing means entropy. So here in case of entropy change is positive, right? So entropy on mixing these two component, that is liquid A and liquid B, the resultant entropy of mixing what you get is positive. And the delta G, that is the Gibbs free energy for this is negative. So this you always remember, right? So this negative, it indicates that this reaction is spontaneous in nature and it will take place without any external factors or external agent. So these are the characteristics of an ideal solution. Delta H of mixing 0, delta V of mixing of 0, delta S of mixing positive, and delta G of mixing is equal to negative. So these all are the properties of the ideal solution, right? So I hope this is clear to you. Chalo. Now, let's see non-ideal solution. So what happened if the solution does not follow the Raoult's law equation? We get the desired equation for the Raoult's law, that is Pt is equal to P naught A minus P naught B into Xa plus P naught B, right? So we get this equation. So if the solution does not follow this equation, then it's said to be non-ideal solution. So what are the non-ideal solution? Just like an ideal solution are what? Which obey Raoult's law, in which force of attraction between solid solvent is equal to the force of attraction between solid solute and solvent solvent. So what is non-ideal solution? How can you define non-ideal solution? So basically, those solution which do not obey Raoult's law over the entire range of concentration, either you increase concentration or you decrease concentration by dilution or anything. So those solutions which do not obey Raoult's law over the entire range of concentration are called non-ideal solution. So they are called non-ideal solution. Now, in this, what about the force of attraction? Obviously, in this, the force of attraction, they are not become equal, just like ideal, right? So when the force of attraction between AA, that is solid solute, and BB, that is solvent solvent, is different from AB, then A and B are said to be non-ideal solution, right? So you get the answer now? In terms of force of attraction, that is the force of attraction in the non-ideal solution are not equal. Like the four, if I'm talking, let's consider, say another example, same example of ethanol and water. Now, if you mix ethanol and water, so how many kind of forces are there? Three kind of forces. One force, if I take ethanol as a solute and water as a solvent. So we have a three kind of forces. The force between the water, that is solvent, and force between the ethanol, that is the solute, and the force between the ethanol and water, right? So in this non-ideal solution, the force between the ethanol and water is not equal to water and ethanol force, right? So they are said to be non-ideal solution. So I hope this is very much clear, right? So what are the characteristics for non-ideal solution? So Raoult's law is not obeyed. Delta H of mixing is not equal to 0. It means you always get some energy release or energy absorbed when mixing two liquid. Delta V of mixing is also not equal to 0. It means if it mix two liquid, if you mix 1 liter of ethanol and 1 liter of water, then you will get either 2.1 liter or 1.9 liter. So you will not get the delta V of mixing is equal to 0. There are always some plus or minus values are there, right? So these are the characteristics for the non-ideal solution. Okay. Okay, now this comes to be a very interesting topic. That is, now we know about the non-ideal solution, right? So non-ideal solution does not follow Raoult's law, right? They does not follow this equation Pt is equal to Pa plus Pb. Not follow means what? क्या हुआ इसका मतलब? वो follow नहीं कर रहा है. What does it implies? It implies either their value is more than this or their value is less than this. right? Only two options are there now. If PT is equal to PA plus PB, then we said to be ideal. Now, what other two options? PT is either greater than PA plus PB or PT is either less than PA plus PB. Only these two scenario are left, right? Because the PT is equal to PA plus PB already covered. So these give rise to the two type of deviation, that is called positive deviation and the negative deviation. So the non-ideal solution can be of two types, right? First, the non-ideal solution showing positive deviation, and the second, that is the non-ideal solution showing the negative deviation, right? So these two type of deviations are present, either positive deviation or we say negative deviation. So let's explore each one. So what is the difference between this positive and negative deviation? So we can understand the whole concept with the differentiating curve, right? So that we can learn this thing in a easy way or compare as well. That is what is the difference between positive and negative deviation. So first and very much important point here, the PT is greater than X naught P naught A into P naught. You already know this thing, right? We already know this thing. For positive deviation, total pressure is greater than this, right? For the negative deviation, the total pressure comes out to be less than this, right? Now, why the total pressure is greater than this? Is there any uh, reason behind this? Obviously, there is reason behind this. Without reason, anything can't happen, right? Everything has some reasons, right? So why the PT in positive deviation total pressure comes out to be more? Total pressure comes out to be more means what? That is, if I'm talking about more pressure, means more vapor. More vapor means what? ज्यादा वेपर कैसे प्रोड्यूस होगा? जब सॉलिड और सॉल्वेंट के बीच फोर्स ऑफ अट्रैक्शन कम होगा या ज्यादा होगा? When more vapor will be produced, when the force of attraction between the solid and solvent is more or less? Tell me fast. Definitely, when the force of attraction between the solute and solvent is less, then more vapor will be produced because they are easily converted into they are easily convert from liquid to vapor state, right? So when the force of attraction between the solute and solvent is less as compared to the force of attraction between solid solute and solvent solvent, then it is said to be, yes, then it is said to be positive deviation, right? So here it will be written as the intermolecular interaction is weaker interaction found in any one of the pure component. That is, the force of attraction between AA, solute solute, BB, solvent solvent is stronger than AB, that is solute and solvent, right? This is nothing but solute and solvent. So if the force of attraction between solute solvent is less, or in other words, we can say that the force of attraction between the solid solute and solvent is more than solid solvent, then it is said to be positive deviation. Just reverse of this negative deviation, the force of attraction between the solid and solvent is more. So if the force of attraction between the solid and solvent is more, then there are less tendency to escape from liquid state to the vapor state, right? So the tendency to produce vapor is decreases, or we say the vapor pressure decreases, the total vapor pressure decreases, right? Now, what is the effect of the positive deviation? So there is an increase in the volume, right? There is an increase in the volume because for non-ideal, we one thing we know, the delta V and delta S, delta G is not equal to 0, right? So what happened for the positive deviation? For positive deviation, the value will increase, right? If I'm talking about delta V of mixing, this comes out to be positive. Delta H of mixing, this is also positive or endothermic. Delta S of mixing is also positive. Delta G remains negative, right? So what are the examples? This is very important because in many questions, they directly asking the example of positive and negative deviation. So you must remember this example in anyhow, right? So what are the examples of the positive deviation, beta? That is water, methanol, water plus methanol or ethanol, methanol, right? So water plus methanol, ethanol plus hexane, ethanol plus cyclohexane, and chloroform and tetrachloride, carbon tetrachloride. So these four are the examples of the positive deviation. Once again, repeat: alcohol and water, that is methanol and water, ethanol plus hexane, chloroform plus carbon tetrachloride, ethanol plus cyclohexane. They all are the example of the positive deviation. Clear है सबको? Now there is a decrease in the volume on mixing and evaluation of heat takes place on mixing. So delta V is negative for negative division. Delta H of mixing is also negative. Delta S is equal to positive. Delta G always remain negative. So what is the example of this? That is nitric acid and H2O, chloroform and acetone, right? H2O plus acetic acid. So these all are the example of negative deviation. If we're talking about the water and HNO3, we have a hydrogen bonding. So due to this hydrogen bonding, the bond becomes strong. They're difficult to break, right? The force of attraction between the solid and solvent becomes strong. So less vapor will be produced. Less total pressure will be produced. So they lie in the category of negative deviation. जल्दी बताओ एक बार, सबको क्लियर हो गया? क्लियर है सबको? टिल किसी को कोई भी डाउट हो बेटा, यू कैन आस्क. आई गिव 1 minute. You can ask any type of doubt you have till now. कैसा भी डाउट हो किसी को, any kind of doubt you can ask, right? नहीं है तो जस्ट हम सब नहीं है. मुझे भी तो पता लगना चाहिए ना डाउट किसको है किसको नहीं है. Is everything clear? I'm waiting for a reply, guys. JNV राजकोट, ठीक है. यस क्लियर है. चलो आई होप सबको समझ आया होगा. किसी को जो भी डाउट हो बेटा, अगर तुम लोग मैसेज चैट कर सकते हो, मैसेज कर सकते हो और अनम्यूट कर सकते हो, तो यू कैन आस्क योर डाउट, राइट? एंड इफ यू आर अनएबल टू डू दिस, देन नो प्रॉब्लम. जस्ट listen to this and try to understand this thing. Okay. So, okay. So, this is the graphical representation of positive and negative deviation. Can anyone let me know which curve represent the positive deviation and which curve represent the negative deviation? Yeah. So this curve is for positive deviation, and this curve is for negative deviation, right? So as you observe in case of ideal solution, which type of curve we get in case of ideal solution? Let me draw once again. So that you understand this curve as well, right? So this curve is between the vapor pressure and the mole fraction. So let us assume if I am considering the vapor pressure of XA is 0, right? And if the XA is 0, then XB must equal to 1, right? Because this solution consists of only two components, that is solute and solvent. So if XA is equal to 0, if the one component is 0, then obviously the second component present in the maximum amount. Now, slowly the value of XA is increased and reaching to this point. At this point, XA become 1. So obviously at this point, XB becomes 0. So this is the criteria for the mole fraction. Now, we get from the Raoult's law. What you get, beta? We know that PA is equal to nothing but P naught A into XA. And what is PB? PB is equal to P naught B into XB. So this is the equation of a straight line. We all know that is y is equal to mx plus c. Y is equal to mx plus c. So this we all know, this is the equation for the straight line. So how will you draw the plot for the straight line, beta? Can anyone tell me? How will you draw the plot for the straight line? Yes, we can draw like this. So this is for PA, right? So this is for PA. Now, as we can observe this, as the value of XA become increasing at this point, XB is 0. Here only which component is present? Only the component A. So at this point, this pressure is said to be P naught A, right? At this point, this pressure is said to be P naught A because this is a pure vapor pressure, because there is no XB here. Only the mole fraction of XA is present, right? There is no XB. So we can say that there is a, at this point, XA become maximum, so we'll get the pure vapor pressure. Similarly, for XB, the value is increasing, so we get the curve like this, right? We get the curve like this. So this is for PB. Here again, this value is not at P not B. Now, if you mix these 2 points, you will get the PT. So this PT is equal to PA plus PB. That is total pressure. So this curve is for the ideal solution. This curve is for the ideal solution, right? So this curve is for ideal solution. Now, how will you draw the curve for the positive and negative, or is it non-ideal solution? So in positive deviation, what happened? Pressure increases now. Yes. So here we can see that this will represent, right? So this straight curve represent XA, right? Here, this one, right? So this is for the ideal solution. Now in the positive deviation, pressure increases. So this curve become like this, right? So this curve represent the increase in the pressure, positive. Similarly, this straight curve represent the negative. So this represent, just see, this represent the मोल फ्रैक्शन ऑफ एक्स बी ना. तो देखो यहाँ पे वैल्यू कैसे इंक्रीज हो गई है बी की. तो ये ऊपर जो वैल्यूज इंक्रीज हुई है अब, दिस रिप्रेजेंट द positive deviation. Now here also in total pressure case, this is the total pressure for the ideal solution. But यहाँ the pressure increase हुआ, so this curve become like this, right? So this is the positive deviation. So in positive deviation, just draw the curve above all the line, like above the total line, above the PA, above the PB, right? So this is all about the positive deviation curve. Similar in the negative deviation curve, just draw the line below the positive deviation, right? For example, this dotted line represents the ideal solution, right? This dotted line represents the ideal solution. So negative deviation pressure decreases, right? So just draw the curve below this ideal line that this has become. This dotted line represents the ideal condition just below this. This dotted line again just below this, right? So this is how will you represent the negative deviation and positive deviation. I hope this is clear to all of you. Yes. सबको समझ आया? चलो ठीक है. So this is all about the positive and negative deviation. Now let's see one important thing. Azeotropic mixture. Yes, yes, sir. Okay, beta. Very good. So azeotropic mixture. So what is azeotropic mixture? क्या होता है azeotropic mixture? जरा समझो ध्यान से. What do you mean by this term azeotropic mixture? So basically, what is azeotropes, right? So they are very large deviation from ideally led to a special class of mixture, right? So they show very large deviation from the ideal solution, and they led to a special class of mixture known as azeotropes. Or we say azeotropic mixture, or we also known as a constant boiling mixture, right? So these are those liquid which just boil at a constant temperature, just like a pure liquid, right? So azeotropic mixture, basically they are the mixture of two liquids, three liquid maybe. In this whole chapter, we're considering only the binary solution. So we're taking only two liquids. So they are the mixture of two liquid, but they boil at a constant temperature, just like a pure liquid, right? Because we know that if you boil water, they have a constant temperature, boiling point like 100 degrees. Right. If we boil ethanol, we have a constant temperature like 74 or 70 degrees. So they are boiled, right? So they are the mixture. They are the mixture. So they're supposed to be possess the something varying boiling point. But no, they show a constant boiling point, even they are the mixture, right? So azeotropic are such mixture which boil at a constant temperature, just like a pure liquid. Right. So liquid mixture which distill over without change in composition are called constant boiling mixture, or we say azeotropes, or we say azeotropic mixture, right? So this liquid mixture are distilled without change in the composition. Their composition does not change either in the liquid state or in their vapor state. Their composition remains the same, and they boil at a constant temperature. Now, a boiling liquid mixture at an azeotropic composition produce a vapor of exactly the same composition, and the liquid does not change its composition. We already talked about this. That is, the composition in the liquid state or in the vapor state remain same, right? They are remain same. So they are the example of the azeotropic mixture. So I hope this is clear. What is azeotropes? So most important one, just remember 1 2 important points from this azeotropic mixture. First, they just boil like a pure liquid and they have a constant boiling point, just like a pure liquid, and their composition are same in both liquid state and in the vapor state, right? So these are the azeotropics. Now, we have two types of azeotrops are known. One is known as the minimum boiling azeotrops, and another is the maximum boiling azeotrops, right? So we have two types of azeotrops, minimum boiling azeotrops and the maximum boiling azeotrops. Let's see. So which will show minimum and maximum boiling azeotrops? So basically, they show deviation from the ideal solution, so they are generally non-ideal solution, right? So the minimum boiling azeotrops are shown by which one? That is the solution which show large positive deviation from the Raoult's law, right? So those solution which show large positive deviation from the Raoult's law, large positive deviation from the Raoult's law, they are said to be show minimum boiling azeotrops, right? So they show minimum boiling azeotrops. So minimum boiling azeotrops are shown by the positive solution, right? So basically the non-ideal solution will show large positive deviation from the Raoult's law. They form minimum boiling azeotrops and boil at a temperature lower than the boiling point of component A and B, right? For example, just write the all the example of positive deviation like ethanol and ethanol plus water, or we can say that as a CCl4 carbon tetrachloride and chloroform, okay, water and benzene, chloroform and methanol. So they all are an example of minimum boiling azeotrops, right? Similarly, maximum boiling azeotrops, basically the non-ideal solution which show large negative deviation from the Raoult's law, right? They form maximum boiling azeotrops which boil at a temperature higher than, because in this the force of attraction is more. They show negative deviation, more force of attraction are there. So obviously they show more boiling point, right? So they have higher boiling point of its component A and B respectively. For example, HCl and H2O, right? And HNO3 and water. So they all show the higher boiling point. So they form maximum boiling azeotrops. So two types of azeotrops we have, minimum boiling azeotrops and the maximum boiling azeotrops. I hope this is clear to all of you. Chalo. So we already done with this. That is all about the Raoult's law. So you already covered Raoult's law in a detailed way. That is what is Raoult's law and what is all about, right? Now, from this, we are going to cover only the colligative properties, right? So we are going to cover colligative properties, right? So what is the colligative property and constituents properties basically? So we already covered the one part of this chapter, that is liquid into liquid solution, binary solution. So we cover Raoult's law for volatile liquid. We already covered the ideal non-ideal solution, azeotropic mixture, and the curve related to ideal and non-ideal solutions, right? So one portion of this chapter is already completed. So try to solve numerical, try to solve, because this part is theoretical only, right? Very less numerical from this ideal non-ideal solution. So try to remember this all the concept and try to learn this thing, right? So that you can able to solve the question. Try to learn the examples of ideal and non-ideal solution. So from now we are going to start a very new the another important part of this chapter, that is the colligative property, right? So this topic carries the highest marks in this chapter. So many questions were coming only from this topic, that is colligative properties. So this is going to be very interesting. So we have going to discuss 4 colligative properties, right? 4 colligative properties है, उन सबको हम डिस्कस करेंगे, उसको सॉल्व करेंगे, बिकॉज सबसे ज्यादा क्वेश्चन जो आते हैं, अगर हमारे मैं नीट की बात करूं, जेई की बात करूं, तो ये सिर्फ colligative properties से आते हैं, right? So this is going to be very 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 important, right? So let's understand what is colligative properties and what is constitutional properties. So let's see the definition of constitutional properties first. So basically those properties which are dependent on the nature of particle, right? So the property which are dependent on the nature of particle are called constitutional properties, like electrical conductance, right? They depends upon the nature of the particle, whether you'll take the insulator or you'll take the conductor, metals you're taking, your plastic you are taking. So the property which are dependent on the nature of particle are constitutional properties like the electrical conductance, right? Similarly, what is colligative properties? This one is very important. Learn this, right? So the property of the solution which are dependent only on the, remember this point, only on the, I'm saying only on, right? So the property of the solution which are dependent only on the total number of particles relative to the solvent or solution, or we can say total concentration of the particle in the solution, are and are not dependent upon the nature of the particle, that is shape, size, neutral charge. These are called colligative properties. So just remember one important note. What is colligative? If someone asks, what is colligative property? You simply say the property which depend only on the number of solute, right? The property which depend only on the number of solute particles, and they are totally independent of their nature, their size, their charge. So they are said to be colligative properties, right? So this is the definition of colligative properties for you. Okay. The properties of the solution which are depend only on the total number of. Okay, good. So there are total 4 colligative properties of the solution that we are going to discuss. The first one is osmotic pressure, and this is very important. And this one is going to be a out of this 4. This one is going to be a very lengthy topic, osmotic pressure. So this one is very important. So there are 4 colligative properties we have. The first one is osmotic pressure. The second one is the relative lowering in the vapor pressure, delta P upon P. The third one is the elevation in boiling point, and how this boiling point affected. And the next one is the depression in freezing point. So total we have a 4 colligative properties, right? That is the elevation in boiling point. Now, one important note here, if someone says, does boiling point or freezing point is a colligative property? What do you say? I'm talking about boiling point and freezing point. Or I'm saying vapor pressure. Is this a colligative properties? Tell me, anyone, if you want to say anything. I'm talking only about the boiling point and freezing point and the vapor pressure. Are said to be colligative properties? How will you define colligative properties? Those properties depend upon the number of solute. So if I'm talking about the boiling point, right? So boiling point of sugar, right? Boiling point of sugar, boiling point of water, right? So they are not colligative properties, right? Because colligative properties depend upon the number of solute. So boiling point, if I consider, if I'm taking 1 liter of water or 2 liter of water or even half liter of water, their boiling point is always 100 degrees, right? So there is no effect on this. So this is not the colligative property. But elevation in boiling point is a colligative property, right? That the elevation that takes place on adding some amount of solute. For example, I'm just boiling sugar, taking 2 grams of sugar in some amount of water and just boiling. So, and now I'm adding more 10 grams of sugar. Now again adding more 10 grams of sugar. So then their boiling point will increase. So elevation in boiling point and depression in freezing point, they are the colligative properties. ये है colligative properties. लेकिन कोई सिर्फ बोले कि boiling point है क्या colligative properties, freezing point है क्या colligative properties, तुम simply बोल देना नहीं. Elevation और depression in freezing point, they are called colligative properties. क्योंकि इनकी वैल्यू जो है ना, वो सिर्फ चेंज हो रही है अमाउंट के डालने पे. कितना सॉल्यूट हमने डाला, कितना अमाउंट हमने डाला, तो अमाउंट की डालने पे जो वैल्यू चेंज हो रही है, that's why they are called colligative properties. क्योंकि colligative properties सिर्फ और सिर्फ किस पे डिपेंड करते हैं बेटा? Only on the number of solute, right? And they are totally independent. They are totally independent on the nature, shape, and size. Let me explain with this an example. Right? If someone says, I have 1 molar of glucose, right? 1 molar of glucose solution. And similar, we have a 1 molar of sugar. So glucose having formula C6H12O6, and cane sugar we have a formula C12H22O11, right? So we have 1 molar of glucose and 1 molar sugar solution. And someone asks, out of these two, which will show higher elevation in boiling point and depression in setting point? So these are the two different substances, 2 different compounds. One is glucose, one is sugar. So out of this, which will show higher elevation in boiling point and which will show lower elevation in boiling point. So I would say they show same colligative property when they have same elevation in boiling point. So they are showing same, they are showing same colligative properties. What do you mean by this? They are saying same colligative properties. And why they are saying showing same colligative properties better? Because colligative property depends only on the number of solute, and they are totally independent of the nature, size, shape, compound, which compound you are taking. It does not depends upon at any point of view. They are depend only on the number of solute particles. So if I'm talking about 1 molar of glucose, we have in 1 molar of glucose, we have 6.023, 10 raised to the power 23 atoms, molecules of glucose, right? Of glucose. Again, in 1 molar of sugar, we also have a 6.023 into 10 to the power 23 atom molecules of sugar. So the number of atom molecules or ion, they remain the same. So how their colligative property will be changed? The colligative property won't change now, because their colligative properties depend only on the number of solute. So if the number of solute remains same, if the number of solute remains same, then obviously colligative property is not going to be changed, right? So remember this thing. Someone maybe confuse you by asking this question. That is, if you're taking 1 mole of glucose, 1 mole of sugar, out of these two, which show more? Just simply say they also same colligative properties, because colligative properties is independent of the nature, shape, and size. They depend only upon the number of solutes, right? Now, one important note here. Now, if I'm taking 1 mole of NaCl, then what? 1 molar of NaCl. Then what? Now, 1 molar of NaCl means what? 1 molar of NaCl, because for this reason only, we are going to study Vent-Off factor in detail later on, right? So, we're going to discuss Vent-Off factor as well. So, 1 molar of NaCl. So, NaCl has strong tendency to dissociate in ions, right? So, we know that 1 mole of Na gives 6.023, 10 raised to the power 23, and 1 mole of Cl also gives 6.23 into 10 to the power 23. So, they on 1 molar of NaCl, they having number of solute particle having 2 Na, right? So they give the colligative property twice as compared to glucose and sugar. So if I am asking you, we have a 1 molar of glucose, 1 molar of sugar, and 1 molar of NaCl. Just due to the nature of ionization and dissociate of NaCl, because they are salt, they are easily dissociate. That's why they are dissociate into the 2 mole. So they give the twice the particle as compared to this. So if I'm saying out of 1 molar glucose, 1 molar sugar, and 1 molar NaCl, which will having more elevation in boiling point or depression in freezing point, you simply say 1 molar NaCl, because 1 molar NaCl having twice the number of atom molecules or ion as compared to glucose and sugar, and due to this only they show this, right? So this is the reason behind this. That is colligative properties. So I hope this is very much clear to you. सबको समझ आया क्या? जल्दी बताओ एक बार. Everyone got it? Got it everyone? सबको समझ आया? किसी को कोई डाउट यहाँ तक? Anyone having any kind of doubt? You can ask. No? चलो. So let's study about the osmosis and osmotic pressure. That is, what is osmosis and osmotic pressure. So before going to study osmotic pressure, which is the our colligative properties, one of them, let's study osmosis before the osmotic pressure, right? So if you know the value of osmosis now, then you can understand that is what is osmotic pressure, right? So what is osmosis? Osmosis is what? That is the spontaneous flow of a solvent particle from the solvent side to the solution side, right? Just remember this thing. The spontaneous flow of the solvent particle. I'm talking about the solvent. The spontaneous flow of the solvent, right? This one is a solvent. The spontaneous flow of the solvent particle from the solvent side to the solution side, or we can say the solution of the low concentration side to the solution of the high concentration side through a SPM is known as osmosis, right? Let me explain with this in an example. So we have two types of solution. This is our SPM. ये चाय छन्नी की तरह काम कर रहा है ये, ठीक है? So this is our SPM, and this is a two type of solution we have, right? This is dilute NaCl, we'll say. This is dilute NaCl, and this is concentrated NaCl, right? So one, we have a dilute NaCl. Dilute NaCl means what? The concentration of NaCl is very, very less. We always can say that here the solvent is more, that is water is more, right? So what is osmosis? So osmosis means the spontaneous flow of solvent. Solvent is what? Water, right? The water. The spontaneous flow of a water solvent side to the solution side, or from the solution of low concentration, because if the more solvent is there, then definitely it will be low concentration. So the movement from the low concentration to the high concentration through the SPM is known as osmosis. Remember this thing is known as osmosis. And what is osmotic pressure? The minimum pressure which must be applied to stop this osmosis. Now, if you want to stop this osmosis, so you need to apply some external pressure. So the minimum amount of external pressure you need to apply to stop this osmosis is known as osmotic pressure, right? So this is how we will define osmotic pressure. So before defining osmotic pressure, you must clear with the osmosis. What is osmosis? What is osmosis? The movement, the flow of a solution from the low concentration side to the solution of the high side, right? This is we known as osmosis. Okay. And so what is the conclusion? So let's see two example of this. In this we put some egg, right? So in the saturated NaCl solution, and this is the distilled water. So in this we have a NaCl solution, and in this we have a distilled water. So what you'll observe, so in a case A, in case of NaCl solution, you observe that grape or egg will shrink, and in the B, you will observe grape or egg will be swell, right? So remember this thing, because in this we are considering NaCl solution, concentrated solution, and in distilled water you are considering only the dilute solution, right? So just remember this. In case of A, the egg will shrink, and in case of B, beaker, the egg will swell, right? So this is all. A raw mango placed in the concentrated salt solution loses water and shrivel into the pickle. इससे हम अचार वगैरह बनाते हैं, है ना? So this is all about the conclusion of osmosis and what is osmotic pressure, right? So this is all about. So osmotic pressure, we are going to start from the that is from next class. We are going to start osmotic pressure. I already told you about how osmotic pressure comes into the picture. That is the phenomena to stop the osmosis is known as osmotic pressure, right? So this is how can you define osmotic pressure basically. That is what is osmotic pressure. Whenever the osmosis takes place, the minimum external pressure which must be applied to stop the osmosis is known as osmotic pressure. So this thing is going to cover from the next class. Till just revise this whole concept what we studied today. Basically we studied today about the graphical representation of the Raoult's law. So this is for the ideal solution. Now we study for the limitation of Raoult's law, ideal solution, characteristics of ideal solution, non-ideal solution, how many types of non-ideal solution we have, like a positive deviation, negative deviation, difference between the positive and the negative deviation, right? And the curve, isotopic mixture, two types of isotopic mixture we have, minimum boiling isotopes and maximum boiling isotopes, and colligative properties. That what is colligative properties and such type of question, very important question, that is out of 1 molar glucose, 1 molar sugar, 1 molar NaCl, right? And osmosis and osmotic pressure. So in next class we are going to start from the osmotic pressure itself. Till revise all this concept, try to solve numerical as much as you can, right? And learn this all important theories, right? So let's meet in the next class. Till take care. Okay.